Hello, this is the second of 5 videos that I have planned on the subject of complex numbers. And in this video, we're going to be dealing with I to the n. There really is no new terminology in this video, but the key in this video is working with exponents. First of all, remembering that I'm using n as any real number. We're not talking about I now, we're talking about things that you have already learned. N to the 0. Any number raised to the 0 power equals 1. Any number raised to the first power equals itself. So n to the 0 is 1, and n to the first power is n. There's something else that I think that we should just include here, and that is that the square root of n squared equals n. And for those of you that like to work with actual numbers, think about the square root of 5 squared. 5 squared is 25, and the square root of 25 is 5. So there we go. When you do this math out, you get the square root of 25, and that equals 5. So that is very easy to show. We learned in the last video that I is equal to the square root of minus 1, and now we're going to calculate I raised to several powers. So I equal the square root of minus 1 is I to the first power. I to the second power will be the square root of minus 1 times the square root of minus 1. And that will equal the square root of minus 1 times minus 1. So we see that from this, that's equal to the square root of minus 1 squared, which is minus 1. So I to the second power is equal to, and start making a chart down here, I to the first, I to the second. I to the first is I to the second is minus 1. I to the third is going to be the square root of minus 1 times the square root of minus 1 times the square root of minus 1. That's the meaning of raising something to the third power. Well, we have seen that this much, we've seen up here that that much equals minus 1. And from the definition, this one equals I. So I to the third is minus 1 times I, or simply minus I. So we'll add that to our little chart down here, minus I. And finally, I'm going to do I to the fourth in a different color, just to make it stand out a little bit for you. I to the minus 1 times I to the minus 1 times I to the minus 1 times I to the minus, I'm sorry, I'm saying I to the minus 1. I to the fourth equals the square root of minus 1 times the square root of minus 1 times the square root of minus 1 times the square root of minus 1. I apologize if I made that mistake with I cubed. And here we have, we saw with I squared that this is going to be equal to minus 1. And we have another one here, so that's going to be minus 1. And minus 1 times minus 1 is 1. So down in our chart, we now have a value for I to the fourth, which is plus 1. Now when I start working complex number problems, I make myself a little chart like this so that I don't get confused. In the beginning, you may have to go through this in order to derive the values of I to the first, I to the second, I to the third, and I to the fourth. But after a while, this should become second nature. Now, let me see what I put. Okay, I also wanted to, let me just draw, let me draw a box around this chart. You may want to add this to one of your keys to working with complex numbers. But if you're going to rely on this chart, make sure it's correct. I to the 1 is I squared is minus 1, I cubed is minus I to the fourth is 1. Now you may at some times see I in some of your problems may take a value, the exponent on I in some problems may take a value that is larger than 4. For example, it may take a value of 7, for example. In these cases, we can use the fact that I to the 4th power is equal to 1 to divide by 1, which doesn't change the value of anything, but using our exponents, I to the 7th divided by I to the 4th is I to the 7 minus 4, which is I cubed, and then we've got our chart here, and that's just going to be equal to minus I. So it turns out that I to the 7th equals minus I. What about, let's try I to the 11th. Well, it's bigger than I to the 4th. We can divide by I to the 4th. That's dividing by 1. I to the 11 minus 4 is I to the 7. And we're right back here. So that, too, is equal to I. Eventually, it's going to be equal to I cubed when we divide by I to the 4th. Again, which is going to equal minus I. So if you play around with a few of these types of problems, and I really encourage you to play with the math, it's not wasting your time. You don't want to just rush through your homework. You want to master the concepts for that day so that you can build upon them the next day. But it actually just wraps around. We have I to the 1st, I to the 2nd, I to the 4th, I to the 3rd, I to the 4th. Then I to the 5th is here, is the same as I to the 6th is same as I squared. I to the 7th is the same as I cubed. I to the 8th is the same as I to the 4th. And it wraps around again. I to the 9th is the same as I to the 10th is the same as I squared. I to the 11th, which we just showed, is the same as I cubed. And I to the 12th is the same as I to the 4th. So you have two methods. You can either extend your chart and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, those being the exponents on I, and they're all going to reduce. No matter how high the exponent goes, it's going to reduce in this way. Or you can continually divide by I to the 4th, which is equal to 1, and not changing the value until you get down to somewhere where your exponent is between 1 and 4. Of course, if your exponent is 0, remember that I to the 0 is going to equal 1. And I would say that would be a special treat in a problem because it would take care of the complex component altogether.